What if a star in our galactic backyard, just 800 light years away, was quietly rewriting the rules of the universe? Geminga, a neutron star that refuses to speak in radio waves, is secretly flooding space with antimatter. It's invisible to ordinary telescopes, yet its high-energy glow exposes a hidden orchestra of cosmic forces. In the next few minutes, we'll trace a trail of evidence, from ghostly gamma rays to colossal particle halos, to a mystery that may decide how matter itself survives. 1. The ghost revealed. Geminga's legend began not with discovery, but with bewilderment. In the 1970s, NASA's SAS-2 satellite and later COSB spotted a brilliant gamma-ray source in the constellation Gemini. But when astronomers searched the skies, they found nothing. No star, no radio pulse, just emptiness. A phantom written in high-energy light. They called it Geminga, a contraction of Gemini gamma-ray source, and, in Italian slang, a phrase that means it's not there. For years, scientists were haunted by this cosmic ghost. How could something shine so intensely in gamma rays, yet leave no trace anywhere else? It seemed unreal, like a secret written in a language no one could read. Then, in 1992, a breakthrough. Rosat, the German X-ray observatory, detected a steady beat, 0.237 seconds, repeating with machine-like precision. It was a heartbeat. Geminga wasn't a ghost at all. It was a neutron star, the remnant of a supernova that exploded 300,000 years ago. But unlike other pulsars, it was different. It emitted no detectable radio signal. It became the first recognized radio-quiet pulsar, a defiance of everything astronomers thought they knew about stellar corpses. NASA's Compton Gamma Ray Observatory, with its Egret instrument, mapped Geminga in detail. Gigantic flows of gamma-ray energy poured out. Yet the silence persisted. Was this a broken pulsar? An outlier? Or the first hint of a hidden family of stars, speaking in light we had never truly understood? European observatories added more clues. Optical images revealed Geminga's motion, a subtle drift across the night sky, proving its proximity, only 800 light years away, practically next door on galactic scales. Close, quiet, but impossibly active. From ghostly gamma whispers to X-ray heartbeats, Geminga forced astronomers to question the rules. A nearby star, blazing with energy but mute in the frequencies we were trained to hear. Yet the real shock wasn't in what Geminga had revealed so far. It was in what it was hiding. Because soon, this silent star would be accused of a crime with cosmic consequences. 2. Halo of antimatter. The silence was unsettling, but the glow? That was terrifying. In 2017, NASA's Fermi Gamma-ray Space Telescope pulled back the curtain on Geminga's true nature. Around the pulsar stretched a halo of high-energy light nearly 20 degrees across the sky, 40 times the size of the full moon. Imagine an invisible storm covering a vast swath of space, invisible to your eyes but blazing in gamma rays. This wasn't ordinary radiation. The glow came from torrents of electrons and positrons, antimatter, streaming from Geminga's nebula at near-light speed. These particles slammed into starlight and the cosmic microwave background, boosting them into fierce gamma rays. The result was a colossal gamma halo, a glowing scar in space. Why did this matter? Because for decades, instruments like Pamela and AMS-02 on the International Space Station had detected something strange, an excess of positrons hitting Earth, far more than theory predicted. The mystery sparked wild speculation. Was dark matter annihilating itself into antimatter? Or was something else hiding in plain sight? Suddenly, Geminga emerged as the prime suspect. Its antimatter halo seemed large enough to explain a huge fraction of the particles striking our planet. Then, in 2025, the High-Altitude Water Cherenkov Observatory, HAWC, delivered the twist. After analyzing 2,321 days of sky data, scientists found halos not just around Geminga, but around many pulsars of similar age. The conclusion was stunning. TAV energy halos are not rare, they are common. Geminga wasn't a cosmic oddity. It was simply the loudest voice in a galactic choir of pulsars, all leaking antimatter into the void. Even silence carried meaning. XMM-Newton and NuSTAR failed to find a diffuse X-ray halo around Geminga. At first, a disappointment. but absence became revelation. It implied weaker magnetic fields or faster particle diffusion than expected, rewriting how scientists modeled Geminga's impact. This once ignored quiet star now stood accused of reshaping cosmic ray physics. Its halo wasn't just light. It was a warning, evidence that the antimatter reigning on Earth might not come from exotic physics, but from an entire hidden population of pulsars. But if Geminga is not broken, merely misunderstood, what other secrets are waiting in its silence? 3. Geometry and the hidden population. The final piece of the puzzle came not from gamma rays, but from geometry. NASA's Chandra X-ray Observatory captured breathtaking images of Geminga's outflows. Twin tails of X-ray light stretching behind it like glowing contrails, and narrow jets streaming from its poles. These weren't artistic flourishes. They were fingerprints of Geminga's spin axis and magnetic fields, written directly into space. When astronomers modeled the angles, the truth emerged. Geminga wasn't truly silent in radio. Its beams were real, but pointed away from Earth. Like a lighthouse whose beam sweeps just above your head, Geminga's radio voice was there all along. We were simply standing in the wrong place to hear it. The gamma rays, however, are different. They spread in broader zones that do cross our line of sight. That's why Geminga blazes in high-energy light while seeming mute in radio. It was never broken. It was always speaking. We just weren't listening from the right angle. This revelation flipped the narrative. Geminga wasn't an anomaly. It was a clue. If its silence was geometry, then countless other radio-quiet pulsars might exist, their beams pointing elsewhere, their halos spilling antimatter across the galaxy unnoticed. Think of the implications. Geminga alone could account for up to 1/5 of the positrons striking Earth. Now multiply that by dozens or hundreds of similar stars hidden in the noise of space. Suddenly, the mysterious positron excess isn't so mysterious. It might not be dark matter. It might be a hidden army of Gemingas. But the story doesn't end here. Because if Geminga is simply one star in a concealed population, then the universe is stranger than we imagined. These stars are not whispering. They are shouting, but only in directions we've just learned to look. And that raises a chilling question. If this much antimatter has been reigning on Earth unnoticed for decades, what else is out there, shaping our fate in ways we cannot yet see? From phantom beginnings to antimatter halos, from silence to geometry, Geminga has shattered expectations at every turn. What once looked like an oddball now points to a vast, hidden population of pulsars, rewriting how we understand cosmic rays and antimatter. The latest revelations from Fermi, HAWC, XMM-Newton, and Chandra are thrilling, but the mystery is far from solved. Geminga is not just one star. It is the loudest whisper of a hidden choir in the galaxy. And the question lingers. How many more secrets are waiting in the dark? Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.